All right, everybody, welcome to topic 5. So in topic 5, we're going to continue our discussion about structures. So last unit, we began our discussion on learning about the structures of molecules, right? How ionic substances always have this positive, negative thing going on, right? And then our metallic substances, right, have the positive ions and then the little negative electrons, C, right? So then you have lots of tiny little negatives, right? And they're just swarming around, right? So this was our ionics, this was our metallic. And now we talked about covalent and how covalent is that idea of we know that the electrons are being shared, right? So here's an electron and then they overlap, share them with each other, okay? But we didn't really dive much deeper into covalence, and that's what topic 5 is all about, is we're going to learn how to draw Lewis structures, which are a 2D representation for covalent structures. Okay, so just like before, it's all about valence electrons. Valence electrons are what are shared in the bonding process, and the pictures we're drawing are only for covalent substances because we're showing a shared relationship. The way that shared relationship gets shown is by these lines. This line represents the bond shared between the two elements, and each of them have donated electron into that bond. So carbon is like, okay, I share one with you, you share one with me, and it helps us fill up our octets. Okay, as you can see in this picture over here, sometimes they can share what's called a double bond. Okay, where in that case, this would represent 4 electrons between them. And there are such things also as triple bonds. Okay, so let's go through the steps here. So first step is we need to know how many valence electrons everyone is coming with, because those are the ones involved in the bonding. So if we look here at our example, we have nitrogen and oxygen. We need to find how many valence electrons they both have. So on the periodic table, if I look there, here's a rough one for us. Okay, I find nitrogen, which is about here, and you count the column, right? So everything here has 1 valence, 2, 3, 4, 5, 6, 7, 8. And so nitrogen has 5 valence electrons. Okay, oxygen is right next to it, and so it comes with 6 valence electrons. And then you do need to notice if it has, right up here, a charge. Okay, so notice up here we have this charge. Okay, then that's going to change the number of valence, not change the number, well, it's going to change the number of valence electrons. In our case, because it's negative, okay, that means we have a bonus. Okay, because electrons are negatively charged, and so if that means we get to add 1. Okay, if it was a -2, then we'd add 2, so on and so forth. Okay, so we'll do that on our next picture here. So let's go ahead and draw what's called the skeleton structure, where the skeleton structure shows their valence electrons and how it's positioned. Okay, the simple pattern is whatever element is first is going to go in the middle. So we're going to put nitrogen in the middle. Okay, and then we're going to put our 2 oxygens on the outside, because once again we had 2. If we had 3 oxygens, right, then we would have drawn a third one down there, so on and so forth. Okay, let's give them their valence. So nitrogen, we said, comes with 5. We're going to go 1, 2, 3, 4, 5. Okay, oxygen came with 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, and then we had our bonus electron. I'm going to make it a different color just to remind us. Whenever you have a bonus, you want to add it to the outside. Okay, so I had 1 bonus. I'm going to pick to put it there. You could have easily, once again, chosen to put it over here. That would have been fine too, but don't put it on the center. Okay, bonuses always go on what we call the outside atoms. Okay, also note in our pattern here with our exception that hydrogen cannot be the center atom. It's too small. It doesn't bond enough times to be in the middle. So if you had a formula that's like H2O and you were drawing it, you wouldn't put H in the middle. You would put the oxygen. Okay. All right, let's copy and paste what we've done so far onto our next step here. Sorry, it's easier for me to do that than for you. Okay. So step 3 is now we're going to start bonding. Okay, the reason why they bond is to achieve a full octet. Okay, so the goal here is focus on the outside atoms. Okay, in our case, that's our oxygens, and we want to get them a total of 8. remembering that the bond counts as 2 electrons for both. Okay, so to start that, I'm going to simply do this and start with a single bond. Okay, and I'm going to put 1 bond here and 1 bond there. Okay, because we know they have to be bonded at least 1 time. Okay, then our next step is to check where we're at. So let's take our picture, copy, paste down here. Okay, so step 4 is, do you want to be checking your octets as you go? Okay, so check your octets. You once again, the goal is to bond up to 8. All the outside atoms should get, well, that's a weird color, should have 8 valence electrons. But keep in mind that hydrogen only needs 2, okay? And the central atom can have more than an octet, and that is okay. But those outside atoms should have just 8, so that's what we're going to focus on, okay? So if I'm looking at my picture here, let's count. Okay, I'm going to count on this side. This oxygen right now has 1, 2, 3, 4, 5, and the line counts 6, 7. Okay, so that means it needs to bond again to achieve its octet. Okay, so I highly recommend the use of a pencil because you might have to move things around here. So notice what I'm going to do is I'm going to take this bottom dot away. Okay, and I'm just going to move it. Oh, maybe it won't let me erase it. Go away, dot. Okay, bear with me here. Okay, so we're going to go like this just so it's gone. Okay, so that's not there, and I'm just moving it over here so I can draw a line better, okay? And then we're going to connect to a double bond. Okay, if I count up again, that gives me 1, 2, 3, 4, 5, 6, 7, 8. This one is happy, and we're done on that side. Okay, let's check our oxygen on this side. 1, 2, 3, 4, 5, 6, 7, 8. He is happy, doesn't need a double bond. Okay, now once your outside ones are happy, you're good, you're done. You can count the middle one if you want. Let's see here. So this one gives, we have 1, 2, 3, 4, 5, 6, 7, 8, which also makes nitrogen happy, but keep in mind it could have more than 8 and it would be just fine as well. Okay. All right, final piece to this. Oh, let's bring our picture down. Copy. Maybe. Okay, there we go. The final thing is if, keyword here, if your molecule started with a charge, we want to show that on our final picture by putting brackets around it and then the charge outside. So that right there would be my final answer for the Lewis structure for our NO2 minus molecule. All right, let's do some practice problems. Okay, so we have the molecule CF4, okay? So carbon's first, so it's going to go in the middle, and then I have 4 fluorines, so we're going to go 1, 2, 3, 4. Okay, look at your periodic table. Carbon comes with 4 valence electrons, so I'm going to put 1, 2, 3, 4 around it. Okay, and then fluorine comes with 7, so I'm going to add 7 to each of these outside atoms. Okay, like so. Got our skeleton and our valence electrons made. All right, so since fluorine here, right, comes with 7 and the goal is to get 8, that means it only needs to bond 1 time. So I'm going to create just 1 bond, which as you can see works out just perfectly because that's how molecules are. And we're done because all of these have 8, 8, 8, 8. Once again, the center one also, because each line counts as 2, 2, 4, 6, 8 also has 8, but it doesn't have to. The center could have more, and that would be okay as well. And there's no charge, so we don't need any brackets. And we're done. All right, let's try NH3 here. Okay, so our nitrogen will be our center atom. got 3 hydrogens, so I'm going to go 1, 2, 3. Okay. Looking at the periodic table, nitrogen comes with 5 valence, so I'm going to go 1, 2, 3, 4, 5. Hydrogen each comes with 1, so each give them 1 dot. Okay. Now, hydrogen is one of our exceptions. Remember, it doesn't want 8. It actually just needs 2 total. So since it comes with 1, if we connect it with another, that gives us our 2. Okay, oops. So we're going to just connect it there, make that hydrogen happy, that hydrogen happy, that hydrogen happy. And then if you look at your nitrogen, it has 2, 4, 6, 8. Everybody is happy and we're good. All right, let's try another one. Okay, we got the SO2 2-, so bringing in a charge example again. Okay, so sulfur goes in our center, and then we have 2 oxygens because of that 2 right there. Okay, sulfur comes with 6 valence electrons, so 1, 2, 3, 4, 5, 6. Okay, once again, where you place your dots really doesn't matter. Just notice we never put more than 2 on a side to begin with. Okay, oxygen also is coming with 6, so 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6. Now we have our charge over here, so that means we get a bonus 2 electrons, okay? Remember, we always add them to the outside atoms, so I'm going to give 1 to this one and 1 to that one, okay? If you have more than 1 to give, spread them out. Don't just give it all to one because we still want to show that it bonds. Okay, all right, check your outside atoms. This one has 2, 4, 6, 7. So to get its octet, it needs a single bond here. Okay, that guy's good. Don't do any more bonding. And then check our oxygen on the other side, 2, 4, 6, 7. So also needs just a single bond here. And we're all good. Okay, now a common mistake students make is they don't check their octets and they just keep bonding, and they would draw like a double bond on both sides. Okay, but if this already has its 8, once again, that counts as 2, stop bonding. Okay, don't do a double bond unless it's needed. Finally, let's add our brackets and our charge. And we're done. All right, I would like you to go ahead and pause the video, and I want you to try this one on your own. And then once you have it drawn, you can unpause it and check with me. And if you got the same answer, then you can have a smiley face. If you have this answer on your paper, you are correct and can go ahead and have a smiley face. Well done. Hopefully that's a good sign that this is making sense. All right, let's do this one together here. So this is just nitrogen, 2 of them bonded to each other. So we have N and N. Nitrogen comes with 5 valence electrons. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. All right, so nitrogen comes with 5. We want to get to 8, so that means we need 3 more bonds. So this tells us right here it's going to be a triple bond. So what we're going to do is we're going to go 1, 2. Now, if you had a pencil, you could like move these dots to a nicer position up here, like so get rid of that, get rid of that, and put it there so it's kind of more in the middle, because that's how triple bonds would be shown. So, but if you had it stretched out, you are technically still correct. Okay, so there's our final answer. Let me erase these here on the bottom so it doesn't look confusing. Right, so once again, the reason why the triple bond came into play is simply because the goal is to get those 8 valence electrons on the outside atom. All right, let's try this one together, and then we'll have you try the last one for a smiley face. Okay, so we got sulfur, 3 oxygens, so sulfur is going to go in the middle. And then we have 1, 2, 3 oxygens. Sulfur comes with 6, so 1, 2, 3, 4, 5, 6. Oxygen is going to come with 6. 1, 2, 3, 4, 5, 6. Continue. Okay. So, oxygen comes with 6, wants to get to 8. So that means we're going to need a double bond on every side because they're all oxygen, right? They're all the same with just 6. Okay, so I'm going to go ahead and do double here. 1, 2. At the top, 1, 2. Okay, over here, let's move this dot. Okay, so I'm going to erase this dot here, put it on this side to make it fit better, and then go 1, 2. Right, so that gives us this oxygen has 8, this oxygen has 8, this oxygen has 8. All the outside atoms, once again, outside atoms are happy, which is what we want. Now, this is the case of an exception. If you do look at the middle, this sulfur has 2, 4, 6, 8, 10, 12. And that's okay. The center atom can have more than 8 and it can still be a stable molecule. All right, go ahead and pause the video, try this one out. When you are done, then go and hit play and check it with mine. All right, so same thing here. Our oxygen comes with 6. That means we're going to need a double bond. So I'm going to move some dots around. Whoops. Oh, erased my C. Okay, so I'm just going to put them on the side there so we can have a double there. Let's move this dot here. And that should be your final answer, is that you have a carbon in the middle, double bonded on both sides. Give yourself a smiley face if you have that correct. Final note is just kind of a vocabulary word to be aware of. It's not something that we will be focusing on this class, but I just want you to recognize if you continue to take chemistry later on that you have the possibility to notice that you have these two structures that look pretty much the same. They just kind of look like mirror images of each other. Right, the double bond and where it's positioned. And right now, if you drew either of these, they would be correct. The true correct answer in chemistry is actually the right answer is that both of them are the right answer, because molecules can actually kind of flip back and forth between two things when you have this mirror image idea, and they are simply known as resonance structures. All right, that is it. You may now go to your homework packet and keep practicing there. Good luck.